Now we'll discuss lecture 30. In lecture 30, mainly we will discuss the transform, which is known as a unilateral is a transform. Okay. Up to lecture 29, we discussed about bilateral transform. Okay. There is a bilateral transform, means uh, the transform we evaluate from n is equal to minus infinity to infinity. X of n is raised to minus n. That's the general equation, and this equation specifically known as bilateral is a transform. Now we will discuss unilateral is a transform. Okay, this unilateral is a transform is also known as one-sided is a transform. Okay, and it is defined only one difference we will evaluate is only from n is equal to 0 to infinity. Okay, here it is from n is equal to minus infinity to infinity. Now it is from 0 to, because normal most of the signals are causal signals, so we need to find out the transform only for the positive side. And another important point regarding the ROC, ROC of because it's a causal signal, so ROC always outside a circle in the Z plane. Okay, something modulus of Z greater than something. Okay, that will be the, so there is no such significance for this ROC. Okay, when it is unilateral is a transform. Now we'll see how we can solve the problems. Okay, here there's a question. We need to find the unilateral is a transform of the following signal: x of n is equal to a raised to n into u of n. Okay, as a non-signal, so we need to find out. Okay, one more point. When it is unilateral is a transform, to know we will indicate some other letters. Okay, that be one-sided. So I can put x1 of z to indicate it's a one-sided is a transform. So x1 of z can be written as sigma n is equal to 0 to infinity x of n into z raised to minus n. Okay, if you take the first signal, is a raised to n into u of n. Okay, as a non-signal, n is equal to 0 to infinity a raised to n, and u of n is equal to 1 for this particular limit, so we can write z raised to minus n. So after simplification you will get z by z minus a, and the ROC is modulus of z greater than a. Okay, it will be same because the given signal is a causal signal. Okay, if the given signal is a causal signal, its bilateral is a transform and unilateral is a transform are same. Okay, we can equate these two, so there is no such difference. Okay, this is one point. So this is the ROC and this is the transform z by z minus a. And now we'll check the next question, that is x of n is equal to a raised to n plus into u of n plus 1. Here u of n plus 1 mean is equal to 1 for n plus 1 n plus 1 is equal to 1 for greater than or equal to 0, means n is greater than or equal to minus 1, and 0 for n plus 1 less than 0, n plus 1 less than 0, it becomes n less than minus 1. So we know that the signal exists from minus 1 onwards. Minus 1 onwards the signal value becomes 1. Okay, 0, 1, and minus 2 onwards it's 0. That is u of n plus 1. But an interesting thing, the one-sided is a transform x1 of z, we will evaluate only from n is equal to 0 to infinity. Okay, so n is equal to 0 to infinity a raised to n plus 1 into u of n plus 1 into z raised to minus n. Actually this u of n plus 1 signal exists from minus 1 onwards, but we are evaluating the summation only from n is equal to 0 onwards. So from n is equal to 0 onwards the function magnitude is 1. So I can rewrite this equation, n is equal to 0 to infinity a raised to n plus 1, you can write a raised to n into a. Okay, and u of n plus 1 is equal to 1, and z raised to minus n. Okay, so you will get a sigma n is equal to 0 to infinity a z raised to minus 1 the whole raised to n. Okay, which is same as the previous question. So you will get finally a z by z minus a, and the modulus of z is greater than a. And for the two questions I will get the ROC same, but there is an extra term a. And if you compare the x of z, that's a bilateral z transform of this particular signal is different. Okay, so which is not equal to x 1 of z or one sided z transform, because this is not a causal signal. Okay, the signal contain negative side also, so we cannot say it's a non-causal signal. So for a non-causal signal the bilateral z transform will not be equal to the one-sided z transform. Okay. We will discuss next question. Actually one property, property of unilateral z transform. See, most of the properties of bilateral z transform and unilateral z transform are same, except this time shifting property, and we need to observe this particular property, time shifting property. For example, if x 1 of z is a one-sided z transform of x of n. Okay, here also I need to indicate it's a one-sided z transform. Okay, here you can see x of n minus m. Okay, it's a time shifted version of the signal. Then its one-sided z transform will be z raised to minus m into xi of z. So this factor is almost similar to your bilateral z transform, but there is another term which is z raised to minus m plus 1 into x of minus 1. Okay, plus z raised to minus m plus 2 into x of minus 2. Similarly, we will evaluate up to z raised to 0. Okay, when it comes to 0 and the x of minus 1. And if it is n plus m, you will write z raised to m. This factor will be same, and extra you can see minus z raised to m x of 0, m minus 1 x of 1, etc., etc. Okay, this is about time shifting property. For example, I'll give you one example how will we write for example x of n minus 2, and the transform will be like this one-sided z transform. We can write z raised to minus 2 into xi of z, x1 of z, so one-sided z transform, plus z raised to minus 1 into x of minus 1 plus z raised to, sorry, already we got z raised to minus 1, there is no z power now, it becomes z raised to 0 actually. Okay, z raised to 0 into x of minus 2. Okay, that's the meaning of x of n minus m. How we can evaluate the one-sided z transform by applying time shifting property. Now we will see problems related to this unilateral z transform. This unilateral z transform mainly used to solve problems with initial conditions. Okay, when there is a difference equation with initial condition, always we need to use the unilateral z transform. Then only we can substitute the values. So here you can see that a signal is given y of n minus 1 by 2, y of n minus 1 is equal to x of n, and the input x of n is given 1 by 3 whole raised to n, and initial condition is also given y of minus 1 is equal to 1. So we need to find out the output y of n. Okay, we need to find out the y of n. What will be the y of n? So we can use unilateral z transform here. So we can write y of z, the y1 of z is one-sided z transform minus now we need to write we need to apply the property x of n minus m here, because here it is y of n minus 1. Okay, if it is y of n minus 1, you need to write z raised to minus 1 y1 of z plus z raised to 0 and y of minus 1. So we need to substitute here. So 1 by 2 is here, 1 by 2 is a common, then z raised to minus 1, y one sided is a transform, plus y of minus 1. Okay, so that's all about this is a transform of this factor. And now we can write the one side is a transform of x of n, that is x1 of xi of z. Now we can substitute this y of minus 1, which is equal to 1. So after substituting this, so now we can substitute this y of minus 1, so it becomes, and we can take y of z common, so y of z into 1 minus 1 by 2 z raised to minus 1 minus if you substitute y of minus 1, then it becomes minus 1 by 2. So we need to multiply this minus 1 by 2. Okay, minus 1 by 2 into 1, so it becomes minus 1 by 2. And x of z we can also calculate. X of z, x of n is given 1 by 3 the whole raised to n into n. Okay, which is a causal signal. So you can write the result like this. One sided is a transform, it's simply z by z minus 1 by 3. Okay, now we can substitute here z by z minus 1 by 3. Now I will rearrange this. One sided is a transform, it becomes z minus 1 by 2 by z. Okay, it's a numerator, and we'll 1 by 2 is the other side, right, plus z by z minus 1 by 3. Okay, now I can cross multiply this z and z minus 1 by 2. So y of z becomes or one sided is a transform, becomes, you can write z by 2 z minus 1 by 2 plus z square by z minus 1 by 2 into z minus 1 by 3. Okay, we got this much. Now we need to perform the partial fraction of the second term. Okay, already in the normal form, so now we need to factorize this particular term. So for example, assume that this I can call it as some let be m of z. Okay, so m of z is equal to z square by z minus 1 by 2 into z minus 1 by 3. So m of z by z becomes z by z minus 1 by 2 into z minus 1 by 3. Okay, now we can write it becomes a by z minus 1 by 2 plus b by z minus 1 by 3. Okay, after simplification you will get means if you substitute, if you take the LCM, it becomes a into z minus 1 by 3 plus b into z minus 1 by 2. Okay, and the denominator will be z minus 1 by 2 into z minus 1 by 3. Okay, we got. Now we substitute z is equal to 1 by 3 and z is equal to 1 by 2. We can calculate a and b. Okay, so a becomes after substitution you will get a is equal to 3 and b is equal to okay, after the substitution b you will get minus 2. Okay, now we can write this m of z. Okay, m of z can be written as m of z by z becomes 3 by z minus 1 by 2 minus 2 by z minus 1 by 3. Okay, and now we can multiply this z to the right side. Okay, here also we can multiply, so I'll write that particular step. So it becomes 3z and minus 2z. now we can substitute m of z here, okay, by using this factor. So here you can see that there is one factor 1 by 2 is z by z minus 1 by 2. Here also one factor 3z by z minus 1 by 2. We can add these two quantities, okay. After addition you will get like this, okay. After it becomes is 7 by 2 z by z minus 1 by 2 minus 2 into z minus 1 by 3. Now I can find the inverse. So y of n or can be written as 7 by 2 1 by 2 the whole raised to n, okay, minus 2 into 1 by 3 the whole raised to n. But we cannot write into u of n because here you can see that signal exists at y of minus 1, okay. So we can write this equation is valid from n greater than or equal to minus 1 onwards, okay. And